An investor's new savings account earns annual effective 3% for each of the first 10 years and annual effective 2% for each year thereafter. The investor deposits an amount X at the beginning of each year, starting with year one, so that the account balance just after the deposit in the beginning of year 26 is 100,000. Determine which of the following is an equation of value that can be used to solve for X. So the last deposit is happening at the beginning of year 26, and we know that beginning of year 26 is time 25. And so we don't care what is happening afterwards, because if we look at all the choices, we are just dealing with those first 25 payments. And let's get started. So this is the time diagram which is useful to say for the first 10 years, the interest rate is 3%. So that's what I've indicated in the bottom here. And then from 10 years onwards, it's 2%. And I didn't even have to go all the way up to 26 because the last payment is occurring at time 25, and that's our last point of interest. So as we said, that the beginning of year 26, that's when the last payment happens. The beginning of year 26 means time 25, because the 26th year is the one from 25 to 26, and the beginning of that year is time 25. So the account value is 100,000 at time 25. But if we look at the answer choices, it seems that they're trying to bring the account value to time zero. And so therefore, let's try to understand what the value of this 100,000 will be at time zero. So the 100,000 is the value at time 25. And if we want to bring this any money value which is sitting at time 25 to time zero, we start applying the discount factors. So the issue here is that we can't just multiply it by new to the 25, which is what we usually do to bring it to time zero. But then usually we have a constant interest rate. Here we have a variable interest rate. So in order to bring this value of 100,000 from time 25 to time zero, we have to go gradually. We first have to bring it to time 10, because from between 25 and 10, we have a 2% interest rate. And then once the interest rate changes, so from 10 to 0, we have to bring it back through another factor. So let's see how it's done. So the 100,000 comes back from time 25 to time 10 through a factor of 1.02 power negative 15. And that's because between 25 and 10, there are 15 years. So 25 minus 10 is 15. And therefore, we multiply the 100,000 with 1.02 power negative 15 to bring its value from 25 to 10. And then to bring it from 10 to 0, we further multiply it with 1.03 power negative 10, because now the interest rate over this period is 3%. And so we multiply by a further factor of 1.03 power negative 10. So therefore, the value at time 0 is 100,000 divided by 1.03 power 10, which is like multiplying it with 1.03 negative 10, and times 1.02 to the negative 15. So we set the 1.02 to the negative 15 first. So that's what is appearing here. We just divide it and change the power to positive. And this is the other factor, which brings it back from time 10 to time 0. So that's going to be, this expression gives us the value of the that 100,000 at time 0, which is the final account value at time 25. And now if we look at it, so we want 100,000 divided by 1.03 power 10 and 1.02 power 15. If we look at the choices, choice A has that, choice B doesn't, choice C doesn't, because here is 16 and 16. We want a 15 for the 1.02. Choice D does, and again, choice E doesn't. So A and D are the only possible choices. And now let's look at the right side. The right side is trying to bring the present value of the deposits to time 0, and that overall present value of deposits up to time 25 should be equal to this present value of the account value that we found. So now let's see, deposits occur starting now, and they go all the way up to time 25. That's the period of interest, because that's the account, we're looking at the account value at that time. So there are 11 deposits from time 0 to time 10, right? From here to here, remember? Whenever you want to calculate how many values are there between 0 and 10, you subtract, you do 10 minus 0, and then you always add 1 to gain a lost one this way, because remember, between 1 and 10, there are 10 numbers. And so therefore, between 0 and 10, there have to be 11 numbers. And 11 deposits from time 0. And all these deposits come back through a 3% rate, because during all these deposits from time 0 to time 10, the interest rate is 3%. So we are trying to find the present value of all the deposits at time 0. So when you bring these deposits back to time 0, you bring it back through a 3% interest rate. And therefore, we have for the first 10 deposits, okay, for the first 10 years, we have a 3% rate. So now if you look at the answer choices, remember we've already narrowed it down to A and D. And we are saying that the first 11 deposits come back through a 3% rate. So if we look at the choices again, so here, these are 10 deposits between 1 and 11, and D also we have 10 deposits between 1 and 11. Actually, there is no difference between this term and this term, so that's not going to decide which is the correct one. But let's just carefully look at what this is saying. When you put K is equal to 1 in this sum, you get X, because this is just power 0, which is 1. And then X means that's the deposit that was just made at time 0. So that doesn't change its value when you bring it to time 0. And then the second one, which was made over here, comes back as X divided by 1.03. And that is what the second term is going to be when you put K is equal to 2. You get 1 over 1.03, and you have this X outside. And similarly, if you go K equals 11, this is X times 1.03 to the 11 minus 1 is 10. So if you bring it up, it's power negative 10. And if we look at here, this was this deposit. This is the last deposit that's occurring in the realm when we still have a 3% rate. So this one, when it comes back from 10 to 0, it's multiplied by a discount factor of 1.03 to the negative 10, which is what this last term is. Multiply by 1.03 to the negative 10, or divide by 1.03 power 10, right? Remember, K is equal to 11, this gives a 10. And so we have to look at what happens to deposits, because this one, the first 10 deposits don't decide whether it's choice A or D, because they're both doing the correct thing. And now let's see what happens to deposits that happen from time 11 up to time 25. So the deposit that is happening at time 11, you first have to bring it to time 10 through a 2% rate. So for that, so here I'm spelling it out. So the value at time 0 of this deposit that's happening at time 11. So first you bring it back from 11 to 10 through multiplying it by 1.02 to the negative 1, which is what I'm doing here. And then to bring it from 10 to 0, I have 10 factors of 1.03 to the negative 10. Yeah, that's what I have here, 1.03 to the negative 10. And similarly, the second one, the next one, which is happening at time 12 over here, it comes from 12 to 10 through 2 discount factors of 1.02. So 1.02 to the negative 2, that makes it from 12 to 10. And then again, from 10 to 0, it'd be 10 factors of 1.03 to the negative 1, and so on. And the last one, the one that is made at time 25. So from 25 to 10, it comes back through 1.02 to the negative 10, a negative 15, because there are 15 numbers between 10 and 25. Yeah, that's what this is, 1.02 to the negative 15. And then it's again 1.03 to the negative 10. So for all of these deposits that are happening, you always have a factor of 1.03 to the negative 10, because at some point they're all coming back from 10 to 0. And so if you add all of these up, you will see you will have an x as a common factor. You will have a 1.03 to the negative 10 as a common factor. And then these will add up from power negative 1 to power negative 15. So let's see here. We already know that it cannot be a, because a is not even employing the 1.03 factor. It's only employing the 1.02 factor. But if we look at d, see all of them have an x. And in the second term, and all of them have a 1.03 to the 10 in the denominator, which is like 1.03 to the negative 10. And then if we open up the k's, when k is 12, this is one factor of 1.02 in the denominator, and up to when k is 26. 26 minus 11 is 15, so that's 15 factors. And if we go back there, this is what we are summing up. The last factor is 15 and the first factor is 1, if you write it in the numerator. So now we know absolutely that it's choice D.